All right, lesson 9.3 is over reflections, which is a transformation that basically flips an image. And we flip this image over a particular line. And so my rule of thumb is every line has a different rule of what you apply to it. So the easiest way to do is to use the line as the mirror. And however far away your image is from the mirror, it's going to be the same distance on the other side. So no matter which direction your line is going, if I have a heart right here, I'm flipping it and it's going to be the same thing over here on this side. All right, so with that in mind, there are a couple of rules here if we're reflecting over the x-axis and the y-axis. So if you reflect over the x-axis, remember this is your x-axis, it's the horizontal line. And what you're doing is you are changing the y-coordinate, making it the opposite of what it was. Because to flip over the x-axis, you're either moving up or down. So that's a vertical movement, so that's why the y changes. If you're reflecting across the y-axis, which is your vertical axis, you're moving horizontally. So therefore you would change the x-coordinate to the opposite. Okay? And here's some examples. If you're at 4, -3, here's 4, 1, 2, 3, 4, -3 right here. And you're reflecting across the x-axis right here. All right, you're going to go up 1, 2, 3 to your mirror, or your line of reflection, and then you're going to go up 1, 2, 3 to the other side. So now you're at the location of +4, +3, which is this answer right here. And if you were at 4, -3 and you were reflecting across the y-axis, here's your y-axis. You're 1, 2, 3, 4 away from your line of reflection. 1, 2, 3, 4 away from your line of reflection over here, which has you located at -4, -3, which is this location right here. So we're just going to practice that, doing that. We also notice down here in this table, we have the reflection over the line y = x. Now if you remember back in algebra, to graph this, your slope is 1, your y-intercept is 0. So it's a line right here, it starts at the origin and has a positive slope of 1. So you would mark your points through here just like so, and we would go backwards as well. And I'll show you what to do when we reflect across the graph of y = x. Okay, so we're starting off with point 2, 3. If we're going to reflect across the y-axis, remember we're reflecting and we're moving horizontally. All right, so if I have point A at 2, 3, 1, 2, 1, 2, 3, and I'm going to do this in a different color. I'm going to pick orange. Da, 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 da. Okay, this is my original point here, A. And let's go ahead and do original point B. -4, 1, 2, 3, 4, 1, 2. There's B. And then 4, -1. 1, 2, 3, 4, -1. That's point C. Booyah. 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 And that's my original image, and that is horrible. I should have connected that line a little bit better there. All right. So now I'm going to reflect across the y-axis. I'm going to underline this in green so I know that my green one is the one that's reflected across the y-axis. So right here, here's point A. 1, 2, 1, 2. There's my new point A. I'm going to call that A prime. B has to move this direction. 1, 2, 3, 4. So I'm going 1, 2, 3, 4. And that's B prime. C is 1, 2, 3, 4 away from the line of reflection. 1, 2, 3, 4 away over here. 1, 2, 3, 4, 1, 2, 3. Yeah, there we go. Okay, so that's C prime, and I can connect those dots. Now, where is A prime? A prime is going to be at -2, +3. B prime, and I'm going to mark that right there. A prime, B prime is going to be at +4, +2. And C prime is going to be at -4, -1. So basically, our little rule, and that's what this AB is for, to say, well, what changed? Well, what changed when we reflected across the y-axis is that our x-coordinate became the opposite of what it was originally. And anytime you want to denote the opposite of a number, you always make it negative, okay? Then your x-axis. Choose another color. I'll go with purple. Okay, all right, so again, here's A, and we're going to call this one A double prime, okay? Let's go reflect across the X, so I'm going to go down 1, 2, 3 to the line of reflection, 1, 2, 3 the other direction, A double prime, and that's at 2, -3. 2, -3. And notice, and again, we're reflecting from our original one. The original point was 2, +3, but it was the y that changed to a negative because we were making a vertical move going across the x-axis. All right, so B right here, 1, 2, 1, 2. Here's B double prime. And B double prime here is going to be -4, -2. Again, don't forget you're looking back at the original point. And then C. C double prime. Let's see, we started right here. We have to move up 1 to our line of reflection. So up 1 right here to C double prime. And that's located at let's see. Yep, +4, +1. I keep looking at this number. So don't do that. Look at your original one that we started with. Okay, and then so anytime you're reflecting across the x-axis, your y coordinate is the one that changes to the opposite of what it was originally. All right, now then, this one's a little tricky. Let's do this one in, what do I want to use? We'll go with red. All right. Reflecting across the graph y equals x. Now, I'm going to show you what you can do, and then you look and see what the trick is to reflecting across y equals x. I'm going to, since this line is slanted, angled, I'm going to turn it just like this. This is my line of reflection right here, and I'm looking at it as if it was a horizontal line. Okay, and if you look at A right here, it's just, if I were to go horizontally, to go directly to that line, like at a 90-degree angle, so it'd be perpendicular with it. It goes right through half a unit. So I'm going to go through half a unit on the other side. That is a triple prime. Okay. Looking at B, if I'm going to go directly perpendicular to this line, I'm going to go 1 unit, 2, 3, and that's actually not 3 units, but 3 diagonals. Then I'm going to go 1, 2, 3 to the other side, and that would be B triple prime. And then here's point C right here. I'm going to go 1, 2 1/2 to the line of reflection. Then I'm going to go 1/2, 1, 2 to the other side. And there's my C triple prime. All right, now then let's write down the locations of A, B, and C triple prime. B, C. Okay. A triple prime right here is at 1, 2, 3, 1, 2. So 3, 2. B triple prime is here at 1, 2, negative 1, 2, 3, 4. So at 2, negative 4. And C triple prime is at a negative 1, positive 1, 2, 3, 4. So negative 1, positive 4. Okay, now forget this middle part. We don't want to look at this middle part right here. We want to compare our transformation with the original points. So notice A was at 2, 3. A triple prime is at 3, 2. Negative 4, 2 is B. B triple prime, positive 2, negative 4. C is at 4, negative 1. C prime, triple prime, is at negative 1, 4. Do you notice that what changed was we just flipped the x and y coordinates? We didn't change the signs or anything. We kept the same numbers. We just flipped the coordinate so that the x was the y and the y was the x. And that is the trick to reflecting across the line y equals x. So here, for our format, if we reflect across y equals x, we're going to flip it just like so. Instead of AB, it's going to be BA. All right, now, a special note. Any line can be used as a line of reflection. Any line, anywhere. And then also you can have double reflection. So that's something that I want to be sure and explain to you. Okay, I'm going to draw the line y equals 1. Y equals 1 would be right here where y equals 1, and it would be a horizontal line where y continues to be 1 in every single ordered pair on that line. Okay, now let's take the points 3, 4, and 4, 2. Okay, and I'm going to graph those. 1, 2, 3, 1, 2, 3, 4. There's point A, and B is at 4, 2. Okay, so here's my image, okay, and I'm going to reflect it across y equals 1. All right, so since this is my line of reflection, I'm going to be doing a vertical move. I go down 1, and so I go down 1 on the other side. That's B prime. A is 1, 2, 3 away from the line of reflection. 1, 2, 3 away on the other side. Okay, and there's my reflected line of AB. Let's see, if I want to do the line x equals 2. Okay, this is where x equals 2 right here. I'm going to draw a vertical line where x equals 2 in every ordered pair on that line. Okay, and I'm going to use these same points, A and B. Okay, so I'm going to reflect it across x equals 2. So this is my mirror. I'm 1 unit away from my mirror, so I'm 1 unit away on the other side. That'll be A double prime. B is 2 away, so it's 2 away on the other side. And there's my reflection across x equals 2. Okay, so and now a double reflection would be, you could have this particular point be starting out, and you can reflect across y equals 1, then reflect across x equals 2. So you do one reflection at a time, and that's kind of what this is referring to. This would be an example of a double reflection. Or you could start on this side, reflect across y equals 2, x equals 2, then reflect across y equals 1. So that would be your example of a double reflection. All right, now the basic on this, guys, to sum it up, wherever your line is, that's your mirror or your line of reflection. Count to that line of reflection, how far you are, and go the same distance on the other side, and you will be in perfect shape. Thank you.